Hello and welcome to Mrs. Law's class. In this lesson, I'm going to show you how to use completing the square to solve a quadratic equation. Now, many quadratic equations can't be factored, and graphing doesn't always give a nice solution, or an exact solution for that matter. However, we do know how to change a quadratic function expressed in standard form, which looks like this, to vertex form, which looks like this. And we can do that by completing the square. So once we have it in vertex form, then we can use the square root principle, like we did in the previous video, to solve for x. So let's take a look at the first question here. So solve by completing the square. So we see that it looks like a function, and the only difference is that instead of it equaling to y, this equals to 0. Now we're going to do something a little bit slightly different as our first step when we're completing the square for an equation. So what I like to do is I actually like to move the constant number to the right side or to the other side. So I'm going to get x squared minus 8x. I'm going to leave a bit of a gap, and this equals to 20. So what I'm going to do is I'm going to write the steps over here on the right side. So the first thing I'm going to do is move the constant term to the other side. All right, now that I've done that, I'm going to complete the square. So on the left side, we're going to take 8 or negative 8. We're going to half it so that we negative 4. When we square that, we're going to get 16. So normally what I would do is I would put plus 16 and then minus 16. Now instead of doing that, I'm actually just going to put plus 16 on the left side, and then I'm actually going to move the other 16 to now the right side. So I'm going to put plus 16 to both sides, which makes sense because I need to add the same number to both sides to keep it equivalent. Now, let me write that down on the right side here. So we're going to complete the square. Okay, so I want to actually add one more part. We're going to put, remember, to add to both sides. So whatever number you get after you half and you square, you're going to add that to both sides. All right, so next we're going to factor. Okay. So on the left side, we're going to factor this now trinomial perfect square. So this is going to become x minus 4 all squared. And we're going to simplify the right side, which is then 36. So now we can apply the square root principle like we've done before, because we have a binomial term and it is squared. So we're going to square root both sides. Then we have the plus or minus. So we have x minus 4 equals plus or minus 6. So x equals, add 4 to both sides, 4 plus or minus 6. So we get 4 minus 6, which is negative 2, and then 4 plus 6, which is 10. So negative 2 and 10 are my solutions. So we have used completing the square to get it into kind of like vertex form. So we have our binomial squared so that we can then use the square root principle to solve. Let's try a couple of other ones, which are maybe a little bit harder because the number in the second term this time is an odd number. So we have x squared plus 5x, and we're going to move the negative 9 to the other side. So we'll leave a little gap. So this becomes positive 9. So we're going to take 5, we're going to half it, and then square it. So that would become 5 over 2, and then 25 over 4. So we're going to add 25 over 4 to both sides. So we're going to factor on the left side. So this will be x plus 5 over 2. Remember that this term here is always going to be half of the middle term from before. So it used to be 5, now it's going to be 5 over 2. Don't forget your square. And on the right side, we're going to get a common denominator. So this will be 9 over 1 times top and bottom by 4. So now we have 36 plus 25. So that will be 61 over 4. Okay, square root both sides. Don't forget your plus or minus. So now we have x plus 5 over 2 equals plus or minus 61 also over 2. Now, if you actually don't ever reduce, you'll notice that the denominators will actually always work out to be the same. So in this case, they're both 2. So when I subtract 5 over 2 to the right side, I'm going to have negative 5 plus or minus, oh, I forgot my square root. So don't forget the square root on the 61. And then this will be all over 2. So this is not a pretty answer, but this is the solution for the second question here. All right, the last one here, let's take a look at what to do when there's a coefficient in the very front, in front of the x squared term. So what we actually have to do is we have to get rid of it. And to do that, we're going to divide every term by that coefficient. So we're going to divide by 2, okay, to every term. All right, so when we do this, we're going to get x squared plus 7 over 2x. And at the same time, what I'll do is I'm going to leave a blank space, and I'll move the 1 to the right. So this will be negative 1, but this will also have to be divided by 2. All right, so now we need to complete the square. So I'll write this on the outside in case you're not sure how this works. So this will be 7 over 2, and when we divide by 2, that's the same as multiplying by a half. So we're going to times by half, and we get 7 over 4. And afterwards, we're going to take the 7 over 4, and we have to square it. So the number that we're going to add is going to be 49, and then 4 squared is 16. So we're going to add 49 over 16 to both sides. All right, so now we're ready to factor. So we have x plus 7 over 4. Remember, it's going to be half of 7 over 2. So this will be squared. And I need to get the common denominator on the right side. So I'm going to times by 8. So I have negative 8, which is negative 1 times 8. So negative 8 plus 49, which equals 41 over 16. All right, then we're going to square root both sides and put the plus or minus. So we have x plus 7 over 4 equals plus or minus square root of 41 all over the square root of 16, which is 4. Now it is a little bit of a coincidence that the one what we just did previous was 61, and this is now 41. That doesn't always happen. All right, last thing is let's move the 7/4 to the right. So we have negative 7 plus or minus the square root of 41. And notice the denominators are the same again, so that's all over 4. Okay, and that's how you use completing the square to solve a quadratic equation. All right, next, let's take a look at an application question. So I'm going to scroll down to the bottom here. All right, so the question says, how far does a soccer ball travel if the function that models its trajectory is given by this function, h of x, where x is the horizontal distance traveled in meters from the goal line, and h is the height in meters. All right, so we want to know how far the ball has traveled. So we need to know this horizontal distance, which means that we probably need to know the x values. So we're going to set the height equal to 0. And I'm just going to rewrite the rest of the function. Now it doesn't look very nice, but usually these numbers always work out. All right, so first thing we're going to do, like before, the last question that we just did, we need to divide by the coefficient in front of the x squared. So in this case, we're going to divide everything by negative 0.016. So when we do that, we get 0 equals x squared minus 72x plus 950. So look at how nice the numbers are now, even though they're a little bit big. All right, so we're going to complete the square. Now I like to have my quadratic on my left side, so I'm just going to move everything to my left side. So we have x squared minus 72x plus, I'm going to leave a blank space, and then I'll have my negative 950, which I'm going to move over to the right. All right, so we're going to take 72, we're going to half it, which is 36. And then 36 squared is actually 1,296. So we're going to add that to both sides. And now we can factor. So this will be x minus 36 all squared. And then negative 950 plus 1296. And we'll just do that on the calculator. Is 346. So square root both sides. So this will be plus or minus. And we have x minus 36 equals plus or minus. Now I don't know what this is, so I'm going to leave it as plus or minus 346. And we're going to move the negative 36 to the right. So 36 plus or minus the square root of 346. So what you're going to do is you're going to go to your calculator and you're going to type these two values out. So you're going to go 36 minus the square root of 346. So I'll do that on my calculator. I get 17.40. Now I'm going to type in 36 plus the square root of 346. And when I do that on the calculator, I get 54.60. So let's interpret what this means. So if I draw a graph, I have a soccer ball and it is kicked from here at 17 and then it lands over here at 54. So this point here is 17.4 and this point here on the x-axis is 54.6. So the question is, how far does a soccer ball travel where the function of that ball is modeled by this quadratic equation or quadratic function? Then we can find the difference between these 2 points. So that would be 54.6 minus 17.4, and that will give me 37.2 meters. So we can say that the soccer ball travels 37.2 meters. So that's from 17.4 on the x-axis to 54.6 on the x-axis. Now, of course, in real life, we wouldn't plot it on the x-axis, but to model the problem mathematically, it makes it easier to put it on a grid. So you can see how quadratic functions and equations can be used in applications.